Today, we're going to build a complete application. In just 62 lines of code, we will validate 10 key concepts that you should know, including do versus while loops and string interpolation. Why? Because validating your skill is the only way to verify your skills. Just like watching someone renovate a home is not the same as building a home yourself, watching tutorials isn't the same thing as building applications. You don't know what you can do until you actually do it. Practice is what separates the dreamers from the real-world developers. Building this app will help you verify your skills in the C# fundamentals. This lesson is part of an overall C# fundamentals skill check course on imtimcorey.com. In that course, we go through this process 4 times, sharpening your skills each time in order to master the fundamentals of C#. If you'd like to take the full course, click on the card on screen or in a link in the description. Let's get started by looking at the application as well as the 10 key concepts we're going to review in this specific application. So I like to call this application numeric leapfrog. It's just a name I give it. You don't have to have a name for it. But this is the type of thing that you're going to practice to verify that, yes, I know what I'm doing. So here's the kind of scenario I came up with. I want you to get close to a number without going over. So you're going to guess a number and you want to get close to the number I'm thinking of. So if I'm thinking of 15 and you guess 5, well, you're not very close, but you'll get another chance. Each guess is added to the previous guess. So if you guessed 5 and then you guess 8, well, that will get you to 13. Okay, so now you're at 13 because 5 plus 8 is 13. When you're within 3, which you are now, the game is over. Or if you go over, the game is over. So you want to get as close as possible and as few guesses as possible without going over. So you would have won with 2 guesses. 5 and then 8, you get a 13. That's within 3 of 15, you win. But if you guessed 16 on your first guess, you lose. If you guessed 8 and then 8 again, that'd be 16, you would lose. So that's the game. Real simple. We're not talking about creating a game that is going to blow the doors off anything, but what it's going to do is it's going to help us validate our fundamental skills in C#. So let's talk about what fundamental skills are we going to actually work on. Well, first of all, user interaction. How do you talk to the user? How do you get information back from the user? And so on. Then we're going to deal with variables, random values, type conversion, if-else statements, while loops, string interpolation, raw string literals, do-while loops. Notice do-while and while because there's 2 different types of loops for 2 different purposes. And then data validation. So those are the 10 concepts that we're going to work on in this small, tiny practice application. Again, the goal is about 62 lines of code to do all of this and have a working application. So with that, let's jump into Visual Studio and start working on our application. So now we have Visual Studio here. We're going to go to create a new project. Wait for it to get loaded. We're going to choose a console app. We're keeping this really simple. And we're going to call this our numeric leapfrog. And we'll call it numeric leapfrog app. And we're going to change the directory here to be the practice directory. Hit next. .NET 8. If you're working on .NET 9, no problem. This will still work the same way. But .NET 8 for now, nothing else selected. We hit create. So what we're going to do first is just deal with some user interaction. So let's get rid of the console statements, and we're going to talk to the user. So the first thing I want to do is just kind of introduce the app to the user. So we're going to say console write line. If you have a shortcut in Visual Studio, it's CW and you tab, and that writes out for you console.writeLine. And you can say numeric leapfrog, and we'll say a number guessing game. And we'll do in our console write line here, get close to the number without going over. basically what I'm going to do is kind of recreate those instructions for the user as well. All right, each guess is added to the previous guess. And then we're going to say when you are within 3 or you go over, the game is over. Okay, and final line here, we're going to say get close in as few guesses as possible without going over. Okay, so that's going to be kind of just tell the user what's going on. And that's one way to talk to the users using the console.writeLine. Now, we're going to deal with another way to talk to the user, still using console.writeLine, but we'll also try console.write as well. And we're going to do one more thing, and that is I'm going to put a blank line here to get some space on our console. So it's not just all bunched together with the next line, the next line, the next line. So the instructions come first, then a blank line, and then I do want to ask the user actually not console.writeLine, console.write, please enter the starting number. So we're going to ask them for the starting number. Okay, so that's kind of the first step in our process is we give them the instructions and then we say, hey, I want you to enter a starting number, but I use console.write so that the cursor would stay on the same line as the request. That way the cursor is right here and they can enter in their value next. So that's what we're going to do next is actually capture information from the user into a variable. Okay, so let's come down here. We're going to say string starting number text equals console.readline. Okay, now I don't know if you know this or not, but one of the things I did is a shortcut. Console readline does not have like a CR tab or something like that, like console writeline does. But if you have the list up like this, first of all, they give you the most common suggestions at the top with stars next to them. But if you're looking at this list and it's kind of long, what you can do, if you hold the shift key down, you can choose the capital letters and type it out. So if I want to get the largest window width, so LWW, watch this. Capital LWW, there we go. It found it for me. And now, since it's one highlight, I can hit tab, and there we go. So that's how I use console.readline. I have to do the RL and tab, and that makes it very quick to put in. Now, this is a string. We're putting our console readline directly into the string. Now, we could do this where we have an empty string, and then we say starting number text equals console.readline like this. But what's going to happen here is this is going to initialize to an empty string, this variable, which is going to take some memory up. And then we're going to create a different memory location to put the value of this when we overwrite it in here. So it's using up just a tiny bit of extra memory for no real value. Since we want to assign a value right away, we can just do this all in one line. Now, it is yelling at us. And this is kind of a bonus one because I didn't even cover this in the 10 thing we're going to learn. This is actually number 11. So this is your bonus. And that is right now, this returns a string with a question mark or a nullable string, meaning console readline can, in theory, return a null value. So if it returns a null value, well, we're not expecting a null value here. By default, strings can handle null values. But with the new nullability features of Visual Studio, what it's doing is it's trying to help us anticipate where there might be a null value by saying, hey, if you don't expect there to be a null value by saying just string, well, then I'm going to warn you that there could be a null value because you wouldn't have otherwise known it. So I can mark this as a nullable string, and then it's like, cool, you are expecting that string to possibly be null. Therefore, we're good. Just know that when you go to use that string, I'm going to ask you to check to make sure it's not null first. But in our case, we don't want a null string. Therefore, what we're going to do is we're going to do a null check, which is 2 question marks, and I'm going to say 0 inside of quotes. So what I've done is the console read line, we're going to read the value, and then if it's null, then we're going to instead return 0 as a starting number. And actually, since we don't want to allow 0, let's do 1. That way you've actually made a guess of some kind. So it's going to be 1 if you give us a null value. So it's either console read line's value or 1. Okay? That way, now that Visual Studio knows that you'll never have a null in this string value, because if this is null, well, this for sure is not null because it's a constant. It's just a actual string that is not null. Okay? So that allows us to make sure that that value is properly checked. But again, this is going to be a string value. We're going to address that in just a minute. But I also want to, and let's put it, for readability's sake, I'm going to put it above the, between the console read line and the console write. We could put it at the very top if we want. That's another way of going by it. I'm going to put some more variables because I think we should put our variables in now. Now, the variables you can put pretty much anywhere as long as you put the variable before you use it. So we could put them in line if you want in the various spots. That can be slightly more efficient, but so slightly that it doesn't matter in a case like a console application. So I like to put them up top because then they're all together, and they're all just in the same spot. So let's actually put them above the console write line even, just so they're not breaking apart the flow here. So I'm going to start with the number of guesses. So that'd be an integer because it's a whole number. So guess count equals 1. Okay, so that's the starting value for number of guesses. We'll start at 1, and you'll see why in a little bit. But that's going to be the counter that holds the number of guesses. Okay, we also need to have a maximum number, meaning the number which the guess is. So like in my example earlier, I said that, if I said the number is 15, well, that's our maximum number. That's the number that you have to get within 3 of, or if you go over or get within 3 of it, we're done. So we're going to call this the max number. Okay, this is the computer's guess. And for now, I'm going to start it off actually with no value because an integer starts off at 0 by default. But we're going to come back to that and put a random number in there. But for now, what we're going to do is just leave it empty. We also need to have the current guess. Okay, so or I'm going to say the current value. So if you guessed, let's say 2, okay, so now the number that I'm comparing against the max number is 2. And then if you guessed 3, well, that's now 5. That's the current value. So again, hold that as an integer. We're not dealing with partial numbers like 1.2. So current value, and we'll leave that at 0 to start with. And then the current guess, like the guess that you are making. So let's go with, let's call this the guess increment. So the first time it's going to be, let's just kind of write this out for a minute. Okay, so the number is 15. That's the number the computer picked. You're going to guess 2, which the value total would be 2. And then you're going to guess 3, so the total value would be 5. Then you're going to guess 2, so the total value is 7, and so on. Okay, so the maximum number is this 15. The current value is this number in parentheses, a total of your guesses. The guess increment are these values, the thing that you gave us that said, okay, I'm going to guess 2, I'm going to guess 3, whatever. So that's the guess increment. So that's kind of the difference between these numbers. And then we have one more variable. We're going to check to see if the number here is a valid guess. So bool valid guess. Okay. And again, Booleans, by default, the value is false. Okay. So that's the default value. Now, these are giving us green squigglies because we have not yet used these down in our code. That's okay. We'll get to that in a little bit. Now, let's address the idea of that random value. So this max number here, I want this to be a random number because I don't want to know ahead of time that it's 15. I want the computer to pick a number. So I'm going to assign it right away to a random value. Random has gotten a lot easier over the years because we don't need to instantiate anything or anything else like that. We can just say random.shared.next. Okay, and this will create for us a random value. Now, this random value right now is going to give us a random integer. We don't want that. We want to specify boundaries for it. So let's specify a boundary of 1 and 50. So a number would be between 1 and actually 49. Okay, so it could be 1. It won't be 50. So it's 1, 2, 3, 4, 5, all the way up through 49. It's not inclusive of this last number. So if you wanted 1 to 50 as possibilities, you would say 1 to 51. All right, just a little thing to note about how random works. So I'm fine with 1 to 50. That's good for me. So that means that the max number, the number you're guessing towards, could be 1, or it could be 49. So you could really have some interesting, times figuring out how you optimize your guesses, or you just try to get lucky. So that's how random works. That's going to populate for us a max number that is going to be random, which means we can play this game over and over and over again, and it will be different every time we play. Right? So that's how random numbers work. So let's talk next. Now we've got this information out of the way. Let's come down here and parse this, because this is a text representation of the guess. So I want to say int.tryParse. We're going to see if that number is a valid number. Okay, so tryParse starting number text. We're going to say out current value. So that's going to be this right here, because the first time we go through is a little different than the rest of the times we go through. The first time you go through, we're going to check to see if we're going to put it right in the current value, because why put it in a guess increment and then just put it right in the current value as well? So we're just going to put it right in the current value, and we're going to do a try parse on this. Now, this try parse, what it's going to do is it's going to either put a number. So if this is null, it puts a 1. If it's not null, it puts this number as a text, and we're going to put that text here. But I'm doing a bit of a shortcut here, because let's just say that you put the value of ONE in your console read line here, which is not null, which means we're going to put ONE in this variable. ONE comes in here, we try to parse it. What happens? Well, it would return false in the try parse, which we're ignoring, but it returned false, and it would do what to the current value? It would put a 0 there. Okay, so if it puts a 0, well, then sure, it puts a 0. Is that a bad thing? Well, no, because it's going to increment your guess count. So if you do something foolish and put a bad value instead of an actual number, so ONE is not a number, it's a string, but if you put, 12, 1, 2, cool, that's an actual number, and that will be valid, and it will put 12 in the current value. But if you type out 12, it's going to put nothing in the current value. Now, we're going to try parse so the application will not crash. However, we can just ignore if it was valid or not, because it's either going to put the number in current value or a 0. But either way, it's going to be a number now in current value. And that's how we're going to do the type conversion for this. Okay, let's clean that up. Now, let's look at how to check to see if we are within that, within 3 or over of our current value. And the way we're going to do that is a while loop. So a while loop looks like this, and a while loop is going to run 0 or more times. So this is kind of the difference between a while loop and a do loop. A while loop always does the check up front, which means that check could fail and it could just skate right on past, meaning it runs 0 times. Whereas a do loop will always run 1 time first. We're going to see a do loop in a little bit. But for now, let's check out the while loop. So we're going to say while current value is less than max number minus 3. So when will this while loop run? Well, it will only run if the current value is less than max number minus 3, which if you are checking out your requirements, that's our escape number. So if the number, let's just put it here in comments for a minute, if a number is 15 and you have, and that's the max number. So the current value, let's just say it is 12. And the max number is 15. And you're subtracting 3. So then this side of the equation is going to be 12. So is 12 less than 12? No, which means the while loop does not run. We jump right past into the next step of our process. However, if our guess was actually 5, well, is 5 less than 12? Yes, therefore we're going to run the while loop. And what it's going to do? Well, if our guess is 5, we're nowhere close to our number. Therefore, we're going to have to ask for another guess. It's going to add to our first number, our 5. So with that, let's come down here and talk to the user and say, hey, you know what? You need to give us another guess. So that's what we're going to do inside of the while loop. Okay, so let's do a console write line that's empty. Okay, because that's going to give us a line break between what you've typed right here, the console write in your entry, and what we're going to tell the user. We're going to tell the user, you're not there yet, but we're going to do something a little different. We're going to use a raw string literal. So here's our write line. I'm going to hit enter inside of the parentheses. And I put 3 quotes. And I hit enter again. What this does is it gives me the ability inside of these 3 quotes on each side, these 3 double quotes, we can type pretty much whatever we want, and including multiple lines, and it will just render on the screen. So this is what's called a raw string literal. And the way it works is you have to have the 3 quotes. There can't be anything after them. 3 double quotes, I'm sorry. The 3 double quotes have to have nothing after them. Now, you could put them on the same line as console write line. I prefer not to. And here's why. Because now that these are in place on their own line, this determines the leftmost side of the text. Meaning, if I were to go space, 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 test, and it prints out in the console, it's going to have 5 spaces before it prints out test. So this edge right here, the leftmost double quotes, indicates the leftmost side of the screen, which also means you cannot go backwards input test. That won't work because you have to go no further left than the edge of that triple quote. Okay, so that's how that works. Okay, also you cannot have anything before this triple quote on the last line. All right, so this is a raw string literal. I'm going to say you aren't there yet. Add another value to your current guess of, we'll get there. You have made X guesses. Okay, so we'll get to here as well. All right, so this is our raw string literal. Why did I do this? Well, remember up here where we did a whole bunch of console write lines? That's a pain because we have to do a console write line for every single new line we want to do. Whereas this way, we just hit enter and we keep going. That makes life a little easier. So now what I'm going to do is I am going to put a $sign in front of this triple quotes. Now, it's still, the left edge is still before the $sign, not the first double quotes now, because of the fact that that's how it works, okay? So, but what this allows us to do is what's called string interpolation, which means that instead of just having a string, I can actually put curly braces here and put C# code inside the curly braces. For example, current value. So add another value to your current guess of whatever the current value is that you just guessed, okay? And the current value, remember, is the cumulation. So it's not just, hey, I guessed 3 last time. Yes, but total you've guessed 8. So, 2 plus 3 plus 3 is 8. I'm trying to do math in my head here. But so it wouldn't say just 3, it would say 8 because you want to know what you're adding to. But this string interpolation allows us to insert a value here that makes it easy for us to see, or makes it easy to insert that value and not have to do some kind of like adding strings together or concatenation or something else. So really easy to allow us to put the value inside, even though it's a raw string literal, because we have that $sign in front of it. Okay, so that's the first one, and you have made, let's go on the next line here. So you have made how many guesses? Well, guess count guesses. Okay, so that gives us the number of guesses that you've made. All right, and that allows us to see, okay, you've made some guesses. How many? Well, I've made 3 guesses. All right, so that's how we would do a raw string literal, and that's how we would do string interpolation, even with a raw string literal. Now, there's one more thing I want to address, and this is one of those nicety things, but this is something that kind of bugs me is, okay, the first time through, okay, we have picked a starting number. Let's say our starting number was 3. And our max number is 15. So we said, hey, is 3 less than 15 minus 3, which is 12? Yes, which means you come in here and it says you aren't there yet. Add another value to your current guess of 3. You have made 1 guesses. Well, that's not correct. It'd be 1 guess. But then if you made 2, it'd be 2 guesses, right? So it's only the first time that's going to look a little weird. And sometimes people, this is the easy way to fix it. You put in parentheses, which that means is guess or guesses. And you figure out what it means. Like you figure out if it's guess or guesses based upon if it's 1 or more. Okay, that could work, but there's a better way of doing that, and it's an inline if statement. So let's come down here and we're going to cut out guesses. I'm just going to get rid of it. I'm going to put another string interpolation code section. I'm going to put this in parentheses. I'm going to say guess count equals 1. Now, I'm going to write this out and then I explain it to make sure that you understand how this works. But question mark, guess. colon guesses. So what we're doing here is an if statement, but it's probably a lot more compressed than you're used to. And normally I like to see if statements on multiple lines. So let's see what this if statement would look like on multiple lines. So it would be if guess count equals 1, and we're just going to say console.write guess. Okay, because it's actually just putting this value in this spot right here. So it's a little different, but let's call it console write. And else console.write, guesses. Okay, this right here is the equivalent of this right here. Now, for readability purposes, typically I recommend that you do this full spelled out if and else statement. And the reason why is because code is meant to be read by humans. So when you're reading, if you're scanning down, it's very easy to miss this one line right here being an if statement. It's very easy to miss that. So I would encourage you to think that through and don't use it all the time. However, in this case, it makes sense because of the fact that it's in line. It's in this line. I could put this whole if else statement inside of this right here. It would be ugly, but I could do it. So the other thing I could do was I could put this if else statement before in the while loop up here and save this guess or guesses to a variable and then put the variable in this spot. But now I'm creating a new variable just for that, and I'm putting that value, storing it somewhere, and then storing it again somewhere else. It's just not terribly efficient. And again, we're talking about tiny, tiny things. It would not be the end of the world. In fact, it'd be just fine and run super performant if you put an if statement and had a variable and all the rest. But technically, it's a little bit more performant not to have another variable. Just kind of giving you all the information here. So how is this line up here the same as this line down here? Well, what Microsoft said was, hey, you know what? We could probably simplify this if statement to be a one-liner. And how we do that? Well, first off, do we need to specify that it's an if statement? Well, no, not if we put the whole thing in parentheses. Okay, so no, we can deal without that. So we can get rid of all of that. And then, you know what? We don't need to have curly braces because we're going to do just one line. We're not going to do multiple lines. Therefore, we can assume that the one line of code is all we're doing. So let's get rid of that. And then else is a kind of long word. Let's replace that with a character. Let's do colon. And then let's get rid of the curly braces there. We're going to do one line for the else. And we need to have some way of differentiating between the end of our if comparison and our statement. So let's put a question mark there. And then we'll not put our semicolons. You don't need those because it's one line. And so now we'll put it all on one line. So let's come down here and do this. And then we can do this. Let's put a space there just for neatness sake. And now you can put a semicolon at the end of that. And we'll just wrap this all in our parentheses just so we have it kind of contained. Now, of course, I'm not doing anything with this, so ignore us for now. This is just pseudocode, not real code. But that kind of gives you a perspective on what's going on here with this line right here. So that's how they kind of trimmed things down in order to give us an inline if statement. So now our inline if statement is going to say, hey, if the guess count is 1, well, then just say guess. But if it's not 1, the else is guesses. So if your first guess, it's going to say 1 guess. You have made 1 guess. If it's a second guess, it's going to say you have made 2 guesses. So now the text looks right, it reads correctly, and it's aware of which one it's doing. All right, so now we have said, okay, you're not there yet. Let's add another value, right? So before we go on, though, I want to do a couple things. First of all, I want to do an empty console write line. So we just give, again, another space here after this paragraph. But I also, and this is very important, I want to say guess count plus plus. Increment that guess count by 1. So again, the guess count all the way up until this point has been 1. Remember, it starts off as 1. But after we have checked out and said, okay, that guess was not correct, we're going to add 1 to the number. Not before we tell them. Otherwise, it would say the guess count of 2 on your first guess. So we want to tell them first, you guessed once, and then increment so we're ready for the next guess. Because we're still inside of this while loop for the current value being less than max number minus 3. We're not done the while loop, but we're continuing in this loop to make sure that we ask for the next information. Now, it's very important to note as well, we're in this while loop and we've not done anything yet to change the current value. So if we get into the loop and the current value, let's say, is 3, and our max number is 15, so 15 minus 3 is 12, so 3 is less than 12. Well, if we never change current value, this will be an infinite loop. Not a good thing. So we'll make sure that we are asking again for another number and doing our next guess, which is going to come up next. So let's ask for our next guess. So to do that, what we're going to do is we're going to come down here. We're going to start with console.write. Please enter a number to add to your guess. All right. And then we're going to say string next number equals console.readLine. And again, I'm going to do the question mark. And I'm going to put the 1 there as well. So this is very similar to what we did right up here. Now I'm saying the next number instead of the starting number. By the way, text. Let's be consistent. I like saying text here because even though I say next number, it's not an integer, it's a string. So I like to say text at the end because we're going to convert it to an integer. Okay, but I'm saying next number here just because it is different. I don't want to confuse people on us saying starting number again or up here saying next number. So we'll have the starting number text and the next number text just because, okay? Just because it's a little bit easier to read. Okay, so now we have asked for another guess. We've captured the string for it. And again, we're going to do a int try parse next number text and out guess increment. Remember, we have this value up here, guess increment. And what that does is it's not the current value. Again, that's the cumulative value. It's our guess. So we're going to add this guess to the cumulative value. So we can actually do that by saying current value plus equals guess increment. Okay, which, by the way, this right here adds by 1, plus it adds by 1, whereas this plus equals is the equivalent of saying current value equals current value plus guess increment. This line right here will be the same as this line right here, but we've kind of shortened it by taking this plus sign and putting it before the equal and saying plus equals. Okay, so that is how we add the guess increment to our current value. That will give us the next value to check, which that's all we need to do before we come back up here to the while loop and do our current value check again to see if it's less than still the max number minus 3. But we've got a problem. And this is one of those sneaky bugs that you need to know about and think about. Never trust the user. Okay, so we want to do some data validation. Now, why do I say never trust the user? Because it sounds kind of pessimistic. And the longer you create applications, the more applications you create in the real world where users actually use them, the more you will get right behind me and say, absolutely never trust the user. Because the user is not necessarily malicious, but the user will do things that frustrate you. They will do things that you did not expect. And if you don't anticipate some unexpected things, you're going to be in for a world of hurt. So when I said, please enter a number to add to your guest, again, what if they said ONE? In their minds, that's a number. It's 1. But to a computer, that's not a number, that's a string. So it cannot convert ONE over to a number. You might say, well, Tim, we have this check right here that's going to put the number 1. No, it's not, because the console readline only doesn't put the value here if the console readline returns null. This is not null. This is a value. So therefore, it would put, we'd capture ONE, we'd put it in the next number text. And we'd try to parse it. And then we would add that guess to our number. Well, what's going to happen when we try and parse this? Well, it's going to say that's 0, and it's going to try and increment by 0. And that's going to be annoying because the user's going to be like, wait, why am I continuing to get more and more guesses without incrementing the value? I typed in ONE. So we want to do some data validation. Now, we didn't do validation up here. We say, you know what? Hey, if you're not putting a valid number in, we're still going to count this as 0. We're just going to start there. But down here, I want to do some data validation and say, no, I'm not going to let you go on until we check to make sure that this number is valid. And that's where we're going to use the valid guess equals, because try parse returns a Boolean. And that Boolean says, yes, that was a valid guess, or no, it was not. Now, why is this important? Because an integer is always going to have some number in it. Okay? It's not a nullable integer, which means it cannot contain null. So it has to have a number. And if this parse fails, it's going to put 0 in the guess increment. But what happens if the user typed 0? Well, that's a valid number. So it could be valid for them to put 0 there. And that would validate and say, yes, that's correct. And the number I'm going to put here is 0. So 0 could be a correct number, a valid number, or it could be an invalid number. The difference is whether they chose to put 0 or whether they typed something incorrect. Meaning, it doesn't have to be just they typed ONE. Maybe they typed 5 P accidentally when they went, or 5 single quote, because that's right next to the enter key, and then they hit enter. Well, that's not a valid number. So we're checking to see if they put a valid number in or not. We're not just saying, oh, you put a 0, you put 0 in every time. So with that, we're going to need to do some type of check, which starts with capturing this as a Boolean to know, is this a valid number or not? Okay, and up here, we have bool valid guess. Okay, so now we know whether or not that was a valid guess or not. The next thing we need to do is some type of loop to say, okay, enter a valid number. Don't just, give me another try. Here's another try. Here's another try until you give me an actual valid number. And to do that, we're going to use a do while loop. Okay, so let's cut this out for a minute. It's the easiest way. You can also right click, by the way, and under snippet, surround with, this also works. I'll show you the surround with. Type in do and hit tab, and it puts my 3 lines of code inside the do parentheses and wraps it with the do while loop. So I often just cut this out and type do. It just seems like it's faster than going to that menu. but it's up to you. Okay, so now we have a do loop. Remember the difference. We've got this do loop, by the way, is nested inside the while loop. Totally fine. The only key is to make sure that you don't have an infinite loop. So we want to make sure we check that when we're done. We've already checked the while loop because we've changed the current value. So therefore, the while loop with this value being changed should at some point exceed the max number. But this do loop, remember, it's going to run one or more times because it doesn't do a check until the end. Whereas the while loop checks at the beginning, so it might run 0 or more times. There's a difference, and it's important to know the difference because it's important to do this check correctly. Here, I want to ask you to enter let's call this now a valid number, just to be clear. But I'm going to ask you up front to give me a valid number. And I don't want to do this outside a while loop and then do it again. So I'll do a do loop where it's going to run at least one time to ask you for a number. This valid guess, we're going to do a check on. Now, you can't do this, like bool valid guess, let's call it 1 because I already got the valid guess. We can't do this because I can't check this outside of the loop. Any variable you create inside of these curly braces, that's what's called its scope, which means the variable does not live outside the curly braces. It goes away, which means I'm declaring a string here. That string goes away at the end of this curly brace. So I don't want to declare a Boolean here. That's why I declare the Boolean at the top. I could have declared it outside the do loop either way. But this way, I can come down here and say, well, valid guess equals false. So now this do loop will continue if you don't give me a valid guess. So if we validate your next number text and it's the number, 1, 2, number 12, well, then that's a valid number. It's going to put true here. True does not equal false. Therefore, we're done. But if you put ONE, well, that's an invalid number. It's going to be false for a valid guess. And so valid guess equals false. Therefore, we go back to the top and run this again. We'll keep asking you until you give me a valid number. So that's how a do loop works and how we can make sure that we are checking that that number you've given us is valid. And we're not incrementing the guess every time. We're only going to increment the guess once so that you're not getting penalized for mistyping something or something else. So that's how to do data validation and then use a do loop to work on that, to use that validation to continually ask the user until you get some type of resolution with your request. Okay, so now this should be all we need to get our current value up to around the max number. Because if the first number, let's just do our guesses here. If the number is 15, our first guess is 5. Well, 5 is less than 12. 15 minus 3 is 12. So 5 is less than 12. Therefore, we go down and say, hey, that's 5. You've guessed once. What's another number to add to your 5? Well, we're going to add, let's say, 8. Okay, so that's going to give us 13. So to add, it's a valid number, so it's going to say, okay, now we are going to add 8 to your 5. That's 13. We're going to come down here to the end of the curly brace, go back to the top to our while, and say, is 13 less than 15 minus 3, which is 12? No, we're done. So now, and if it was, we go through the whole process again. So our while loop is complete. Now we can do is we can come down here and say console, leave a blank line here. Blank lines are good. They really help separate things. So don't be afraid to put a few extra if it helps make things readable. Okay, so now what I want to do is figure out if you've won or if you've lost. And that's going to require an if statement. So an if statement, we're going to say if, and I'm going to say current value is less than or equal to max number. So not number minus 3, just if you're less than or equal to max number. So if our current value is 12 and our max number is 15, then yes, 12 is less than or equal to 15. Therefore, you win. If it was 15, is it less than or equal to 15? Yes. Therefore, you win. If it's 16, is it less than or equal to 15? No. Therefore, you lose. So this first section, the if section, is going to be if you win. Console write line. Let's do it on multiple lines. So we're going to do our string interpolation plus our raw string literal. And I'm going to say you win! Exclamation point. The max number was, so that's what the computer guess was, or computer's number was, because you should know that. And you guessed current value, period. It only took you guess count, how many guesses you made. Guesses. Okay, and that's our console statement for the winner. There we go. That's our winner statement. So now let's do the sorry you lost. I almost called you a loser here, but console write line again. Let's do our raw string literal and our string interpolation, and we'll say sorry you lost. The max number was max number, and you guessed current value. It took you guess count guesses before you went over. Okay, so there's our else statement for the loss. That's our if and our else. And kind of wrap this up, I like to put a console.read line at the end. What this does, if you're not familiar, is it's going to ask for you to type some value. But the other thing it does is it pauses the console until you hit the enter key. The benefit there is if you're running this application outside of Visual Studio, meaning if you're running it in VS Code, I'm not sure if Writer does it or not. I believe it would be necessary for Writer. But if you ran this as an application, just the executable itself, the console would close as soon as it typed out your win or loss statement. It would just close. But this way, it keeps the console open and shows you that message until you hit the enter key, and then it closes. Now in Visual Studio, it actually keeps the console open anyway because of debugging purposes. But I don't like to just rely on Visual Studio for that because I want to make sure that we don't just rely on Visual Studio for taking care of those needs. And if you notice, I'm at line 63. That's I'm one short, and this is the reason why I think it is right there. I put an extra space here where I wasn't anticipating doing. So there we go, 62 lines for our application. But we're not done yet. This is a really important part of building an application is we've got a lot of assumptions in here. Now, I intentionally, because of time, for time's sake, I have not run this application yet. But it's really important that you try out your applications, you test them thoroughly before you just declare them valid. So let's do that now. So to validate, we're going to just run this application, and we're going to try it a few different ways. And I don't know what the guess is, okay? So there's our message. Please enter the starting number. Let's start with 5. You aren't there yet. You add another value to your current guess of 5. You've made one guess. Notice the singular guess. Let's add 4 to our number. Hey, I win. The max number was 10. I guessed 9. Only took me 2 guesses. Thank you very much. I'm awesome. Okay, I obviously can't plan that because I don't know what the number is. However, I want to point some things out. First of all, the application works. Awesome. And if you look at the spacing here, it's pretty good. We have the line spacing in the right spot, but there's a really important point about software development that newer developers often miss. And that is when you're testing your application, you're not done right now, okay? The application worked. Great. And you might say, hey, I'm done because the application worked. No, you're not. You say, oh, you know why? I didn't test the I lost scenario. Okay, I'll test the I lost scenario, which we need to do. So starting number is 1. I'm not there yet. How about 55, which I know goes over? You lost. You guessed 56, took you 2 guesses, but the number is 21. Okay, I kind of exceeded that. But you lost works. Therefore, the application works, right, Tim? No, not yet, because you haven't thoroughly tested it. How do I know? Because you haven't thought like a user yet. You've done what I call the happy path, which is that you have entered expected values at every stage. Let's think like a user. Enter a starting number and hit enter. You aren't there yet. Add another value to your current guess of 0. You've made 1 guess. Enter a valid number and enter again. Oops, I guess it's not going to let me do anything. Enter a few more times. Still not let me do anything. ONE. Nope. Put in quotes 2. Nope, that's not going to work. Let's put a 300 typed out. Nope. I don't know. 3 period. Nope. 3.4. Nope. So see what I'm doing here? I'm trying different values that might be put in the command line. True. Nope. False. Nope. $1. Nope. Like 4%. Nope. So I'm trying all these things because I want to validate that my application still works properly when I give it some bad inputs. We don't want it to crash when the user gives us bad inputs if we can help it. Now, sometimes if we can't do anything about it, we have to crash. And that's a valid way of handling really bad input if there's no other way to deal with it. But in our case, we have ways to deal with it. In fact, we just asked the user to keep guessing. Now, the first one, I entered bad input, and we just accepted it as a guess of 0. It's kind of a penalty for that first one. We could go back and wrap this top one in if statement 2, but I kind of wanted to have that little bit of a penalty at the start. But now we are not allowing you to continue until you give me a valid number. So I give it a valid number now of 5. We're not there yet. So see, it popped right through. Let's try it again. Yes. Nope. Okay, so I have to give it a valid number of 3. I win. Hey, I'm really good at this. The max number is 9. You guessed 8. Only took you 3 guesses. So there we go. Now what I've got is a working application that is not just tested on the user giving us good information, but I've also tested it on the user giving us bad information and checking to make sure that it still holds up even when they do. That the user can't kind of bypass this and just crush our application. By the way, notice the cursor's down there. If I enter again, that's when it closes the application. Any other place, if we're running this in VS Code or on the command line or as an executable standalone, this section of text right here would not pop up. This is a debugging section of text that's just for Visual Studio that kind of allows you to keep this window open for a little bit extra. Enter, goes away. So now we have tested our application, and now we have a working project. Tiny, it's only 62 lines of code, but we've tested a lot of different things. We've dealt with user input and output. So we've outputted write line and write, and we have done the read line to capture information. We have variables that we store information in. We have dealt with random numbers and how to generate them. We have done things like parsing and whether or not we care about if the parse succeeded or not. And we did the null check here to put a value in if the return value is null. We dealt with the while loop and how that executes 0 or more times. We dealt with an inline if statement. We did increments of a number by 1 and also adding one number to another using the plus equals. We saw how to do a do loop, and a do loop that was nested inside of a while loop. We, again, did another parse. We did some user or data validation to make sure the data that user gave us is valid, and if not, keep asking them instead of just crashing the application. And we also saw how to do a full if statement and then do our string interpolation here as well as our raw string literals. So lots of stuff here in just a little application. And the value of doing this little application that puts together these little things that you've been learning is that you not just verify, oh, I know how to do an if statement, but I know how to do an if statement inside of a larger application. By larger, I do not mean a massive application. Again, 62 lines, but in an application that has a number of things working together in concert to do something. So it's not just an if on its own, it's an if inside the context of this application that has all these other things. This is important because if statements don't live on their own. When you are going to get into the real world and you're building real applications, you don't just do things in an isolated environment. You have to work within a context and build an entire application, not just know what the syntax is for if. Okay? So the difference between knowing what the syntax is and knowing how to use it. And the best way, really the only way to really become a developer who can do things is by doing things, by building applications. When I say practice, this is what I mean. Small, tiny applications, 62 lines. But this tested a lot of your knowledge in putting it together. So this is how I test your knowledge with one application. In the full course, we have 3 more to go. So we have 3 more applications like this. In fact, the last one is the reverse. I've written an application and you've got to debug it. So there's 9 bugs you got to find. It's a bug hunt. I actually call it bug hunt. But before that, there's 2 more applications similar to this, but with slightly different flavors so that you can try out other things that you've learned in the foundational C# knowledge and make sure that you know how to put these things together. And the benefit of doing this over and over and over again is that you really ensure that you are kind of polishing what you've learned. The more times you do things, the more comfortable you get. And I want you to be a confident developer. And so confidence comes from doing. And so if you do it over and over and over again, you start to say, yeah, I've done this. Oh, string interpolation, not a problem. Hey, raw string literal, not a problem. Hey, a while loop, got it. Oh, no, actually that should be a do loop because I want it to run one time at least. So you'll get to start doing this over and over. So the full course has 4 of these, but this is a standalone. This is one of those 4, and I want to show you how we do these skill checks at I Am Tim Corey to make sure that your skills are up to date, but also to polish those skills so that you're a confident developer. If you want the full course, go to iamtimcorey.com. If you're a DevPass subscriber already, you already have access to this. Go ahead and go through the rest. Make sure to polish those skills. It does not matter your skill level. Polishing your skills will always provide a benefit to you. I'd also encourage you, when I show you the application, say, hey, we're going to build this, I want you to practice by doing it first, then coming and watching me. That gives you an additional level of validation that you can do this. Take those steps and keep going, keep building as a developer, because that confidence will translate into better and better development skills in your life. Thanks for watching, and as always, I am Tim Corey.